Okay, Assalamu alaikum. Welcome back. So what I want to do today is just a super quick review and answer questions about data management with Room. Then I want to start introducing reading and writing data to Firestore. So while doing this quick review, please let me know if you have any questions about Room, since you already have one lab on this. So hopefully things are a bit clearer. So please, I encourage you to go through the slides again, go through the examples, ask any questions you have. So what I want to do now is just to remind you that for the example, first of all, that we have done together last time, we created an app that uses three tables. We have the category table, and a category, let's say, for example, fruits, vegetables, bakery, and then each category has one or many products. There is a one-to-many relationship between category and product. So for example, for fruit, we have apple, banana, orange, and so on. And then I can search for these products and add them to the shopping item and specify how many items do I want to buy from this product. And what you see here is basically an entity relationship diagram. It's a very commonly used diagram to describe the structure, or we call it also the schema of our database. So now in terms of programming model, when you want to use Room, you basically need to create entities, which are nothing but data classes annotated with some @annotation. And we have data access objects, which are interfaces that have methods. And these methods are annotated with queries. And finally, we have the Room database that acts as the main access point to allow us to use data access objects to read and write. So just to quickly remind you, this is how the entity looks like. It's a normal data class. On top of it, you add the annotation @entity. And then you basically go ahead and annotate one of the attributes to one of the properties of the class to be the primary key. So in our case, the ID is the primary key, and it is auto-generated, which means the database will take care of assigning an ID whenever an item is added to the item table. So by creating this annotated data class, I basically create an entity in my program, and Room will create a table corresponding to that entity. So I have a class item, and I will have table item. And the properties of my class become columns on the table. And that's basically the idea of entities. I am telling Room, go ahead and for each class I annotate with entity, go ahead and create a corresponding table in the database. Now to read and write, I simply create an interface. And in this interface, I provide the methods to read and write. For example, here I want to read all the users from the table and return them as a list of users. So I create a function, make sure it is preceded with suspend to indicate that this function should run in a background thread, not in a main thread. And I come to this method and annotate it with this annotation @query and specify the SQL query that Room should execute to return me the desired result.
Doctor,
Yes, please.
is it mandatory to put its suspend functions? Can some function be not suspend?
It is best practice to put suspend. I think if you don't put suspend, you will get a runtime exception saying you cannot run database queries on the main thread. So you must put suspend. There are other ways, of doing it, but the latest and the best way of doing it is by putting a suspend, by making all the methods in your interface, in your data access objects interface, making them as suspend functions. This way, you are 100% sure when you call them, you always call them as part of a coroutine, and you call them in a background thread. So for example, in here, if I show you in my repository here, or in my, let's say, in my view model. So when I call this guy, yes, you can see here when I call this function, I put it inside the coroutine. I run it on the IO thread. So this way, because I marked it as suspend, I cannot just call it a normal way. I cannot just call it like this. So this will fail. It will say this is a suspend function. You can only call it within another suspend function or within a coroutine. And this
Doctor,
yes, please.
we're talking about here the DAO interface, not the
Yeah,
view model,
the
yeah?
same thing. Like the DAO, I don't access that. That's a good question. I should not access the DAO interface directly from my view model. I call it from my repository, and the repository will expose them as suspend. So what I mean here, because I mark them as suspend, because I marked them as suspend in my DAO, when I call them from the repository, I should also mark them as suspend. So to summarize, yes, whenever you create a DAO, make sure you mark all the methods as suspend. So this
Oh,
way, you are forced to run them within a coroutine in a background thread.
we did it in the lab without suspend and it works.
Anyway, that's not the good,
For,
not the
for
best.
here line, for here line 21, why is not suspend?
Line 21. Where is line 21? Because yes, except if there is a live data that I will explain shortly. With live data, you don't put suspend. So in the lab, it's not the best practice. The best practice is put it as suspend, and also best practice is to run it on the IO thread like this. At the end of the day, when it is a run, it is a run on the IO thread. This is the best way of doing it. Otherwise, you might be running it on the main thread.
Okay, thank you.
Yeah, welcome. So it might work, but that's not the best practice. The best practice is not. We remember, like we had a full 2 or 3 sessions on coroutines, highlighting that you should leave the main thread for UI updates only, not run anything on the main thread. And by marking your DAO functions as suspend, you don't forget about this, and you are forcing yourself to really run them in the background threading, specifically in this scenario, because it's reading and writing. In this particular scenario, it is best to run such functions in the IO thread. So like this in here. So I launch it in the view model scope. I launch it and I use dispatcher IO. And this dispatcher IO, as you can see here, is designed for offloading, blocking IO task to shared pool of threads. Yeah. So this is the proper way of doing it. All right. That is for basically the second thing, where the programming model of when you use Room. First thing, you create your entities. Second things, if you create your DAO interface with all the methods and you mark them as suspend. Now for queries, when you are reading from the database, you annotate your functions with @query, and then you specify the query statement. Select star from user. In this scenario, for example, I want to return the first user. In this scenario, I want to return all the users. And that's all I do. And then room will actually generate the actual implementation. I don't need to implement these functions. I only specify the method signature and an annotation specifying what query should the room execute to return this data from the database. Now for inserts, updates, and deletes is even easier. You don't need to specify the inserts and update statement. You only need to add the annotation at insert. At insert, you can insert a single object or even multiple objects. So in here, it will insert multiple users in the database. You can also delete a particular user or multiple users in one go. You can update one user or multiple users. All you need to do is annotate your insert, update, and delete methods with the appropriate annotation. And then Room will generate the actual insert statement or update statement or delete statement. It will submit it to SQLite database and do all the work on your behalf. Now, once you create your entities and you create your data access objects, it's time to create your room database class that puts everything together. And in this room database, it should be an abstract class that extends the room database, and it must be annotated with the annotation at database. And in this annotation, you specify what are the entities in your app. List all of them, comma delimited as an array. And then inside this class, you provide a get method for each data access object of your app. Each data access object in your app, you must provide a get method inside your room database class. And then you provide a static property. In this case, I called it DB instance. And this static property, we make it static using companion object to be able to create a single instance of the shopping DB. We only need a single instance. The first time it will be null, and then we go ahead and actually either create the database from scratch if it doesn't already exist, or just connect to it and provide a connection to this database. And subsequent calls, we will just return the same instance. So this method here, this trick here, ensures that in the whole app, we have one single instance of shopping DB. And then the room database class, which is in our case the shopping DB, is the main access point. It gives us access to the DAOs to read and write from our database. Okay, final thing I want to show you here. If I have something like this, let's say a query that let's say here reads from the whole database and then returns a list of items. I can mark it as suspend, and basically this will run it once, get the results, and that's it. Now, if I want to make this as ask room, please go ahead and watch for me the item table. Whenever the item table change, I want you to let me know and give me the new results of this query. Whenever the item change, run this query and give me the new results. And basically all you need to do is wrap this result in a live data. By doing so, you are basically instructing room not only to give you the results of this query, but also to watch this table, and whenever that table change, it will automatically notify you. This is so powerful, as you will see shortly here. So if I have, here is my app here. Here is my shopping items. I don't have any shopping items yet. Let's add one. So bakery, let's say go for, let's say cake 3, add. Let's go for another one. Let's say fruit. No fruits, vegetables, no problem. cards 10, and let's add this. So I have these two items here. Let me refresh. And watch this whenever I change the quantity. If I change the quantity here to 5, this gets automatically updated. I change the quantity in the table to 20, this will get automatically updated. Just by coming to the results of the query and wrap it in a live data. That's all you need to do. And this will make it observable query, which means whenever the underlying data change, the table will the results will change, and the UI will be automatically notified. I think it will also work in here. Let's say carrots. Let's make it with S. You see here it changed immediately. So powerful. Um, let's say cake. Cake, cake, cake. Where is cake? Here is cake. Allahu Akbar. I'll make it cakes. Change automatically. Because in the query here, let me show you the query. Here's my shopping item. And the query, no, shopping item DAO. Take a look at the query. The query is basically joining, if you see here, the query is joining shopping item with product, joining these two tables and returning the results. So by the fact of putting live data around the results, that's all I do. The room is now watching both tables. Whenever any of them change, I get new results and I refresh my UI. And in terms of UI, there is nothing special. It's an observable, I observe it, and whenever it changes, like in here, it's an observable, I observe it, shopping list is an observable, I observe it, whenever it changes, I let the adapter know, and that's all. Now, you might be wondering, will the user really go to the database and change it manually like this? No, that's not realistic. So what happened in real life, you might have some online database using Firebase or some server on your own, some database on your server, and you might be reading periodically in the background. We will see how to do this next week, inshallah. So you might be reading some queries, querying the server on the background, reading some new data from the server. And all you do with the data that you read from the server, you might write it to the database. And automatically the UI will be updated. And this is really powerful, as you can see, with minimal effort. So that's basically the idea of observable queries. Now, finally, we had a couple of things that we didn't really emphasize too much. Maybe you already seen nicely in the lab. The first thing is type converters. And basically, type converter is if you are using some data type, such as, let's say, in our scenario here, in my shopping item, I'm using this data type here, date, which is not really supported by SQLite. So SQLite, when it's storing date, it stores date as a long number, as a long integer. So there is no kind of direct support for the date data type. So if I don't do anything and I try to run my app, the app will not compile, and Room will tell me I'm not able to write a date property to a date column in the database. Now, to give it some help, what I do, I go and create a type converter. And a type converter is nothing but a class that tells Room, oh, by the way, if you come across a date and you try to write that date to the database, so basically go ahead and change it to long. So this converter is a helper function that allows room, whenever it tries to write a date value, it will first convert it to long by going to the date object.time. This will return a long value representing that particular date. Now, same thing when it reads. Now, when we read this column, so room will read this column and it will try to write it in the class. It is declared as date. So from long to date, we need to convert from long to date, and that's why we are providing this two dates. We give it a long value and get back give it a long value and we get back a date. So I mark these two functions as type converters, as type converter, and then I let my database know about this type converter. I'll say, oh, by the way, be aware that there is a date converter in case you need it. If you come across any date attributes, or sorry, any date property in a class, in an entity, if you come across a date property in an entity, take that date and use this converter to convert it to long when you are writing it in our case to an updated date column. Whenever you need to write to the updated date column, take the value from the object and convert it to long. And when you read from the database, read it as long, then convert it to a date before you write it into the entity property. So without this type converter, the database will not be able to handle a date column or a date data type. And that's very simple syntax, as you see. So I create functions annotated with type converter, and then I let my database class know about these type converters by adding this annotation type converters and specifying the name of the class implementing all the type converters. Okay, so I hope it's clear. Now, there's one more scenario that you might encounter. So what I have here, I have a user class. It has some simple attributes, ID, first name, last name. Those are no problems. Those can be mapped to columns in the table, no problem. But for the address is an object, is a nested object. Now, Room will have a hard time storing this in the table because a table, as you know, those of you, especially those of you who took database course, you know that table can only store a simple, can store values of simple type, such as int, string, and so on. It cannot store an object. So that's why we tell in Room, please take care and go to this object, take the properties of this object, and make them as columns in my user table. So you can see here in my user here, I have an entity called user, and this user has an embedded, has basically an attribute of type address, which is a data class. It's not really an entity. It's just a data class. If I just keep it this way, Room will complain. I will say, I will not be able to help you to store an address in the user table. Now we say to Room, please, this is how you should handle it. Make the properties of the address as columns of the user and take care of this for me. Whenever I write the properties of the address to the columns and vice versa. When I read from the columns and I write them to this object. So you can see my table here. You can see my table. It has these three columns coming from user and these three columns coming from address. And these three columns were added thanks to this add embedded annotation. So when do we use this add embedded annotation? So in the case, we use this in the case where we have a class with a nested object. We can mark the nested object as embedded. And this way, the properties of the embedded object becomes columns in the corresponding table. So my user table, not only it has these columns, but it will also have the columns corresponding to the address object. Okay, so I hope it's clear. So this is what this embedded is used for. And the final thing, no, two more things left, is this foreign key relationship. So what you can see here from this example I showed you, so here I have a category such as fruit, vegetable, bakery. This is a category. And a category has one or many products. So for example, product has, let's say, for fruits, we have banana, apple, orange. So, and how do we link these two tables? How do we establish a relationship between these two tables? So in the product table, I specify a category ID. So basically, when you can see here when I insert, here is my category, and you can see I have vegetables category. You can see here vegetable category 2. If I go to my table, all the vegetable categories have category ID 2. Okay, so this is called the child table or the many-side table, and this is the parent table. So the category is the parent table. And these two tables are linked with this. This is called foreign key. So this category ID is a foreign key associating product with category. Okay? So how do we create this foreign key? So let me first show you the advantage of having this foreign key.
Victor, so the product table is the parent and the category is the child?
No, it's the other way around. So the category is the one side. The one side is called the parent, and the product is called the child. So basically, what we have here, it's a one-to-many relationship. Which one is the one side relationship? Which one is the one side of the relationship? Is the category. One category has how many products? Many products.
Many.
For example, for vegetables, we have, let's say, potato, onion, carrots. We have so many products under that category. So we call the category as the parent table and the product as a child table. And we link the two by using a foreign key. So category ID is called the foreign key, linking product with the category. So for example, in here, if I try to insert, let's say, a new vegetable, let's say a red onion, and basically in here, this is the name of the product, this is the image of the product, and this is the category of the product. And I run it, no problem. If I go back to my product and I go to the end, refresh, go to end, I will see my red onion here. You see it? My red onion here. Now, if I try to add something for a category that does not exist, because here the categories I only have 2 to 6. If I try to add something, a product for a category that does not exist, this will fail because the foreign key that I specified. So you can see here, it says here foreign key constraints has been violated. You cannot insert a product for a category that does not exist. And by defining a foreign key, the database will enforce this rule for you. You don't need to do any programming. It will be enforced. If somebody tries to insert a product for a category that does not exist, what will happen to that insert statement? It will fail. The other thing the foreign key gives you, the other advantage foreign key gives you, if I go ahead and delete the category 2, which is the vegetables, what will happen is also the products that are associated with that category will also be deleted. So take a look at this. Here are my products. I have so many, if I go up here, so many vegetables. As you can see here, many vegetables. Once I go ahead and delete the category vegetable, something went wrong. Anyway, when I delete that category vegetable, that particular product, sorry, when I delete the category vegetable, that particular, those products belonging to that category will be deleted. So as you saw here, let it just come back. Here is my products. All the vegetables are now gone. Okay, so defining a foreign key gives me two advantages. Defining a foreign key gives me two advantages. The first advantage is I cannot insert a product for an invalid category. Second advantage, if I delete a particular category, all the associated products will be automatically deleted. That is why we go ahead and define foreign key relationships between tables. And how do we do so? So very simple. All I do, I go to my product table or product entity, and I will say, oh, by the way, I want to create a foreign key between the ID of the category table and the category ID of the product table. So in other words, I want to link this category ID with the ID in the category table. I want to link these two, which means if somebody tries to insert a product, they can only do so for category IDs that exist in the category table. If somebody tries to insert a product for a category that does not exist, that insert will fail. The other thing I can also specify, I say here on delete cascade, which means if a category is deleted, what will happen to the products associated with that category? They will also be deleted. Okay, so that's basically the idea of foreign key constraints. So foreign key allows me to do integrity check. Here is another example. I have a pet and I have an owner. So an owner has an ID and name, and a pet has a no, this is basically ID. The pet has an ID, a name, and an owner ID. So a pet belongs to an owner. Pet belongs to an owner. So what I can do, I can define a foreign key relationship between the owner ID, between the owner.id and the pet owner ID. So this way, if I try to insert a pet for an owner that does not exist, this will fail. Also, if I delete an owner, all the pets owned by that owner will also be deleted. So to achieve this, I simply go ahead and define a foreign key to associate these two columns. Also, I can create an index. An index is just a way of speeding the query. So an index, you see in most textbooks, at the end of the book, what you find is an index. What do we find in an index? What is an index? Have you seen an index before at the back of the book?
Yeah, it has the titles and a
Yeah.
number of the page.
Yes, it has it has some keywords and the page number. So if you're looking for a keyword, instead of going through the book one page at a time and looking for that particular keyword, what you need to do, what's a better way of doing it? You go to the back of the book, you go to the index, you look up that keyword, for example, foreign key in a database course, in a database textbook. Definitely in the index you will find a keyword called foreign key, and then you will find all the pages where the foreign key was mentioned. So an index is just a way of speeding up queries. So in here I'm asking the database, please also create an index for me on the owner ID. This is a nice to have, it's not a mandatory, it's not required, but very highly recommended. Whenever you create a foreign key on a particular column, you also create an index on that column to speed up the query. Okay, last thing, which I don't have really a running example for it, but just to show you here. So imagine in here, in this same example, I want to read all the owners, and then for each owner, I want to go ahead and read the pets of that particular owner. Of course, I can do it in multiple stages. For example, I might do, for example, select star from owner and put this in a list and put this in a variable, let's say owners, which is basically a list of owner. I can do this, and then I can basically do for owner in owners, I can go ahead and get the pets. Get the pets for that particular owner. So I can do this. I can run this query, and then for each of these owners, I run a query to get their pets. Now I can also ask Room to do all of this for me in a simpler way by creating a class to hold the results. So the class to hold the results will be owner with pets. It will have the owner details and then the list of pets belonging to each owner. So what we will have here is basically for each so what I'll do, I'll take the owner and make it embedded, which means when I read from the owner, I ask Room, please go ahead, get the owner details and put them in an object of type owner. And then in the background, also go ahead and get me the pets related to that owner. But we need to tell Room what is the relationship. How do we connect pet with owner? We say that there is a relationship between these two guys. So for each owner ID, connect it or link it, or there is a relationship based on the owner ID. So this column belongs to the pet and these columns belong to the owner. So this is a one-to-many relationship between the pet and the owner. There is a one-to-many relationship. For each owner, you can see here how they have one or many pets. And for each pet, how do we link it back with the owner? Using the owner ID. So pet, as you saw here, a pet has an owner ID. So how does the owner relate to the pet? So this is the parent column and this is the child column. This is how they are related. So we tell Room this relationship. We say this is the ID coming from the parent entity, which is owner, and this is the entity column coming from the pet entity. And this way, Room is able to connect each owner with its pets. Now, once I do this, I am able to go ahead and read owners with pet by simply doing select star from owner. That's it. Room will do exactly what you saw here. Room will do what you see, what you're saying here. So instead of us doing this ourselves, we are asking Room to do this on our behalf. And because there are many queries here, we can mark them as transaction to make sure if one of the queries fail, the whole statement will fail. So this is just a shortcut. Instead of getting the owners and then looping through them and getting the pets, I can do it in one statement like this. Just select all from owner, and because I already told, and I'm asking Room, please return me owner with pets, and the owner with pets defines this embedded. Embedded means take the owner details, put them in an object of type owner, and then go ahead and read all the pets belonging to that owner. And how do you link the owner with pet? Is basically get me all the pets where the owner ID, pet owner ID equals owner.id. So it will do exactly the same as this, but this is much simpler and much shorter. So I hope it's clear. This is we only use this for simplifying a one-to-many queries by using the add to relation on top of our many-side entity. So I hope it's clear. If it's not, please let me know. I can clarify further. So this is the summarized. So basically, the Room is a library that allows us to simplify reading and writing from a database. So we need to program three components: create entities that define the table structure. We go to our data classes and add this annotation add entity. And then we go ahead and create DAOs, data access objects, which are nothing but an interface with functions. And these functions are annotated with add query or add insert or add update or add delete. And finally, we create a database class that puts everything together, and it gives us access to our data access objects so we can interact with the database. So that's basically the summary of Room. So you have these nice slides having all the concepts that you need. You have this nice running example that illustrates all the concepts. Hopefully you already played with this in your lab, and I'll be releasing the base solution on the project so you can start applying this to your project and things will become much clearer. If you need to go deeper, either if you have time now or in the future, these are some extra resources that you can take advantage of. Okay, that's it for reading and writing data or managing data using Room. Let me know, please, if you have any question. Otherwise, I basically want to super quickly just give you a glimpse of what will be next time. In the next session, inshallah, I'll be talking about Cloud Firestore. Cloud Firestore. So if you have a multi-user environment, or if you have, which is typically an app is used by many people, and you want to do some data storage and data processing, you may, in most cases, need some server-side database, some database that you put on the server to store your data and manage your data. Of course, you can go ahead and set up a server by yourself, install the database of your choice, such as SQL Server database or a MongoDB or so many other databases out there. Or you don't need to set up any servers or install any databases yourself. You can just use an existing cloud database where you can easily read and write data on your in that particular online database. So one of such online databases that's very widely used, it's called Cloud Firestore. and this is a product from Google. So if we go here and say Cloud Firestore, you will see here it is. So this is Cloud Firestore. It's a part of a bigger product suite, which is Firebase. So Firebase, it's a much bigger set of products offered by Google, and they provide all these services. Don't worry too much about them. What we want to use for now, at least, we want to use authentication to do login for users, to be able to make to enable our users to log in, and then we want to use Cloud Firestore to read and write data on this Google Cloud. That's all we want to use for now. There are other services, of course, that you can explore later. There is also cloud storage if you want to store, read, and write files. I think these are the three services we will be using. One service for authentication, reading, like basically verifying the username and password, and one Cloud Firestore to store data, structured data in a Cloud Firestore database. And then we have cloud storage to store and retrieve files. And for the rest of the services, we are ignoring them for now. So to make use of this, what you do, you go to this console.firebase.com, create an account, basically log in as create a Google account or log in using your Google account, your Google username and password, and then create a project. Create a project, and then in that project, for example, here I already created a project. I called it CMPS 312 Fall 2020. I go there, and I can access from this project. In this project, I can have many apps. For example, so far I have 2 apps that are using this project. I have a restaurant review, and I have a shopping list app that I will explain, inshallah, next time. And then for these apps, 2 apps, I can use any services that I wish. But as I said, we will be using 3 services in this course: authentication and Firestore, Cloud Firestore, and storage to read and write files. So 3 things we will be using. Okay? Now, if I go to authentication, and here I'm just giving you a very brief overview. Next session I will, of course, show you this in much more details with examples. So for authentication, I can go ahead and create usernames and passwords. This is the simple usage scenario. I can create username, emails, and passwords. And when in my app, when people come to my app to use my app, I can ask them to log in. So I just want to give you a glimpse, and of course next time, inshallah, I will explain this in much more details. So for authentication, let me just show you a small example of how this looks like. When somebody wants to authenticate, I'll do something like this. Authentication, which is a class that comes with Firebase Auth. First of all, before I can use this Firebase online services, I need to go to my build.gradle and add these dependencies. So I'm adding dependencies to Firebase, Firestore, authentication, whatever service I want to use, I add a dependency in my build.gradle file. I add all the dependencies, and then I can start using these dependencies to interact with these online services. So for example, for authentication, this is how I do it. I create an instance of firebase.auth, and then I can say, here is my username and password. Please go ahead and sign in for me. Sign in with email and password, give it the email and password, and then I wait on completion. on completion. If it's successful, I'll do this, otherwise I do that. So it's very simple. And this will basically verify this username and password with the username and passwords that I have created here on on this online app. Okay, that's the first thing you can do with Firebase authentication. With Firestore, you can basically store you can store, let's say, users here. So each user has an ID, and these are properties of the user. This is another user, and these are the properties of that particular user. And here are restaurants. This is the name of the restaurant, the city, the photo, price, and so on. So in here, I am storing documents. Similar to JSON document. Remember JSON document we have been seeing in this course? So Firestore, you can think of it as a way of storing JSON documents. And these JSON documents are stored in collections. So Cloud Firestore allows me to create collection of documents, and each collection I can store documents and I can query them. So for example, just to give you a glimpse, now of course I will explain this more next time. So for example, if I go to I can say here, shopping item.get and await. Basically, I'm getting all the documents in this collection. I can also do where clause, where no, before get. Basically, I put it here, where equal to, where, for example, product ID one, two, three. So I can go to that collection and say, give me all the items in my collection where the product ID happens to be 1, 2, 3. And because this is asynchronous, I'll wait for it and return the results. It gives me a list of documents, and I convert these documents to a list of shopping items. So it's a very simple model where I can basically store documents and query them. That's the idea. If I want to add, I go to a collection and say, go ahead and add. If I want to delete, I go say, go to this collection, go to this document having this particular ID, and go ahead and delete it. Yeah. So that's basically the idea of this. So inshallah, next time I will explain this in much more details with examples. All right, thank you very much. If you have any question, let me know. I am online here.